Here's a fun fact. This is the first species we've covered that we're actually filming on the site of their native locales. From when they're just a tadpole in an egg in a river to all throughout adulthood, the spotted salamander has a little green in their body that gives them a competitive advantage. Chlorococcum amblystomatis is that algae. And you might be thinking, how is the algae able to photosynthesize while being inside their body? Sunlight can't get in there, can it? Well, kind of. The eggs themselves are surrounded in a net of the single-celled green algae. However, even when they're born, the tadpoles have little specks of algae throughout the inside of their bodies. The skin of the tadpoles is so thin that some, not a lot, but some, sunlight is let in and allows the algae to photosynthesize. It was thought for a long time that this was the end of it, that this was the end of the algae's lifespan. Everyone thought, well, as they grow up and their skin thickens, there's no way the algae survives. But they were wrong. Although as their larval stage advances, as their skin thickens, and as they grow arms and legs, fewer algal cells are able to survive, probably because of the lack of sunlight. This still raises the question though, what about the ones that do survive? Well, they hide in the spotted salamander's skin, deep enough so as not to be bothered, but shallow enough to still reach sunlight. And I know how that sounds. A plant wedging itself under their skin? That sounds rather painful, doesn't it? Well, remember, this takes place slowly over time, and the specks of algae themselves are very, very tiny, near microscopic. Although they are able to hide out in the stomach of the tadpole and still photosynthesize, times change. So as the salamander matures, the algae spreads out. Although it's most common to see algal cells in the skin, they are still seen in the gut. The gut algal cells were always damaged in some way, spilling out their membranes, with thialcoid membranes just floating about. The thialcoid membranes are the parts of the plant cells that help them photosynthesize. However, the most curious location that you'll find algal cells within would be the salamander's genitals. Yes, even the reproductive tools are full of algae. For the males, the algae wasn't in the testes like how you'd think. Nope. Instead, they were in the Wolffian duct and the Mullerian duct. The Mullerian duct, in males, is a remnant of what usually develops into female reproductive organs during their larval stage, and as such is a non-functional part of their bodies still intact. The Wolffian duct, the other duct that you'll find the algal cells within, functions as both a sperm depositing system and a connected part of their kidneys. So algae is found in both. That's probably how algae is retained through generations, right? It clings to the sperm and hitches a ride inside the fertilized eggs during mating, right? Kind of. Only kind of. Except the algae is also found inside the female's oviducts and medial ovary. In fact, there's even more inside their oviducts than there are in the male's ducts. Though that then raises the question, how do algal cells inside the reproductive ducts photosynthesize? Good question. They don't die either. They just reproduce inside the tadpole, and then their cycle may continue. So they have algae that helps them photosynthesize. How exactly does that help the spotted salamander? Well, all the salamander really needs is to keep producing carbon dioxide, and they'll have an unlimited supply of glucose. That doesn't mean that they don't still eat normally, though. In the wild, they tend to gravitate towards any invertebrates they can fit in their mouth, since they are primarily insectivorous, unless you count the glucose, of course. They'll usually eat worms, beetles, ants, and, when times are tight, smaller salamanders. Outside of eating and mating, they spend a majority of their lives underground. It's only during the spring that they come out to reproduce, and they do it in droves. In fact, for a while, it was becoming a bit of a problem because the spotted salamanders would have to cross the road to get to their breeding grounds. And as you can imagine, this was sometimes fatal for the salamanders. They would become roadkill. However, the cities in the United States where they are most numerous decided to install salamander tunnels under the road so they can make it across safely. Their other threat is less easy to sort out though. Herbicide. Since a lot of their laying grounds are surrounded by urbanized cities, herbicide is an unavoidable issue. And although it doesn't hurt the salamanders directly, as far as we know, it does kill the algae that lives inside of them. And it's found that clusters of spotted salamander eggs without the green stuff are a lot less likely to survive. All that makes it sound much worse than it is. These are very real threats for sure, but keep in mind that their population numbers are at a stable least concern on the IUCN Red List. So, despite the herbicide and despite the past of being threatened by cars, it looks like they'll be good now and in the distant future. So, good on you, spotted salamander, and congrats on the photosynthesis. That'll be it from me for today, though. Thank you to the spotted salamander. Despite the wealth of knowledge we have on their algae, there isn't a whole lot aside from that they have going on that differentiates them from most other salamander species. But that's okay. Thank you for just existing. All right, I'll see you later. Goodbye.